it's no secret that all 1968 model cars sold in the United States, as well as a large number sold in Canada, will be equipped with exhaust emission control devices. The Chrysler-built cars you'll be servicing will be equipped with a cleaner air system, or CAP for short. I think it's a good idea for all of you technicians out there to get acquainted with CAP before these new models arrive on the scene. For all practical purposes, you'll be servicing the same CAP system that California technicians have been maintaining for the past couple of years. So, I've asked Jim and Larry, a couple of crackerjack California CAP-type technicians, to tell you all about CAP. Suppose we kick this session off by letting Jim explain what CAP is.
Sure thing, Tech. As you probably know, CAP is designed to reduce engine emissions to acceptable legal limits. That means controlling both crankcase and exhaust emissions. Let's consider the crankcase emission problem first. Until a few years ago, a road draft tube was commonly used to vent blow-by gases from the crankcase. This was a simple and effective way of venting crankcase pressure. And when the car was moving, so that pressure was reduced at the lower end of the tube, a stream of ventilating air moved through the crankcase. Several years ago, the draft tube was replaced by a tube connected into the base of the carburetor. This arrangement provides positive crankcase ventilation, since manifold vacuum is used to pull fresh air in through the oil filler cap to sweep fumes out of the crankcase. CAP-equipped cars go one step further. The oil filler cap is connected to the air cleaner instead of being open to the atmosphere. In other words, CAP cars have a positive, fully closed crankcase vent system. With this setup, if the crankcase vent valve becomes plugged or blow-by is excessive, crankcase vapors are vented into the air cleaner and burned in the engine. This prevents crankcase vapors from escaping into the atmosphere under all conditions. Controlling engine exhaust emissions is a bit more difficult. The exhaust contains small amounts of hydrocarbons, which simply means unburned gasoline and carbon monoxide.
At this point, I think we ought to clear up a few facts about our non-CAP engines. Our engines are both clean and efficient under most operating conditions. I think it would be easier for everyone to understand CAP if they understood why certain operating conditions produce relatively high emission from non-CAP cars. Suppose you tackle that part of the lesson, Larry.
Okay, Tech. On non-CAP cars, exhaust emissions are highest at low engine speed and when decelerating. But I better explain why these particular operating conditions cause relatively high emissions. That'll make it easier to understand how CAP reduces these emissions. When decelerating, the throttle is at idle position, but the rear wheels are driving the engine at faster than idle speed. On the intake stroke, the piston works like a vacuum pump, but the nearly closed throttle limits the amount of mixture pulled into the cylinder. This mixture isn't dense enough to ignite easily. To make combustion matters worse, the exhaust valve opens before the end of the power stroke, and some exhaust gas is drawn in. This dilutes the mixture so that it doesn't burn completely. As a result, unburned and partly burned fuel goes out the exhaust pipe. Next, let's consider the low-speed emission problem. On non-CAP cars, a relatively rich idle mixture is used in order to obtain smooth idle operation at low engine idle speed. Of course, a rich idle mixture results in more hydrocarbons and monoxide in the exhaust. I think that pretty much explains the emission situation on a car that isn't equipped with CAP. So let's explain what's different about a car that is CAP-equipped. The specially calibrated CAP carburetor delivers a lean idle mixture. There are no significant changes in the calibration of the other carburetor circuits. Only the idle circuit calibration is affected. The basic timing of CAP engines has been changed to provide a retarded ignition at idle speed. However, the mechanical and vacuum advance systems of the specially calibrated CAP distributor are essentially the same as for a conventional distributor. The vacuum control valve ensures maximum vacuum advance of ignition timing during deceleration. It does this by controlling the vacuum applied to the distributor vacuum advance mechanism. But to understand how this works, we better take a look inside the valve. The chamber on one side of the valve is connected to both the carburetor vacuum port and the distributor vacuum advance. The chamber on the other side of the vacuum valve is connected to manifold vacuum. A spring holds the valve closed. The vacuum control valve is normally closed, but strong manifold vacuum acting on the diaphragm can overcome spring pressure and open the valve. Here's how the valve works under various operating conditions. At engine idle speed, the vacuum valve does not affect timing because manifold vacuum is not strong enough to open the valve. Only vacuum from the carburetor port is acting on the distributor vacuum advance, and it's not strong enough to advance the timing. During acceleration and at cruising speeds, manifold vacuum is still not strong enough to open the vacuum valve. Only carburetor vacuum is acting on the distributor, but it's now strong enough to provide normal vacuum advance, just as it does in a conventional ignition system. During deceleration, the throttle is closed. Carburetor vacuum is low and not great enough to provide distributor vacuum advance. However, manifold vacuum is very high, and it opens the vacuum valve. With the vacuum valve open, high manifold vacuum takes over to provide maximum vacuum advance during deceleration. This is quite different from the non-cap car, where there's little or no vacuum advance during deceleration. Because the ignition timing is greatly advanced on a cap car, during deceleration, combustion starts earlier, and there's more time for more complete combustion. As a result, exhaust emissions are reduced to an acceptable level.
Now that's what I'd call a mighty good explanation of what CAP is all about. There's just one bit of information about emissions during deceleration that I'd like to add. The torque converter in a torque flight transmission is designed to be more efficient when the engine is driving the wheels than it is when the wheels are trying to drive the engine. The torque converter lets the engine slow down much more rapidly during deceleration with a torque flight equipped car than it does with a manual transmission car. Because of this rapid engine slowdown, emissions are acceptably low during deceleration, and there is no need for the advanced ignition timing provided by the vacuum control valve.
You mean the 1968 models with torque flight won't have a vacuum valve?
That's the way I got it from the engineering grapevine, Jim. Only manual transmission cars will have the vacuum control valve. Now, here's another point I want to clear up. There's a lot more to clean exhaust than recalibrated carburetors and distributors. A lot of refinements and design improvements have been made in combustion chambers, manifold heat control, engine temperature control, and fuel mixture distribution. And now I think we better talk about servicing CAP cars. Maintaining a CAP-equipped car is primarily a matter of performing ignition and carburation inspections, adjustments, and service that should be performed periodically on any car to ensure efficient engine operation. Don't you agree, Jim?
I sure do, Tech. For instance, spark plugs must be cleaned and inspected at least once a year or every 12,000 miles. If the center electrode is worn, it should be filed square and flat and the gap adjusted to 35 thousandths. When installing plugs, correct torque is very important. Replace spark plugs every 2 years or at 24,000 miles. It's very important to use the correct plug type and specified heat range. The wrong plug will raise hob with both performance and emissions. Annual inspection of the distributor is important. Distributor contact points must be replaced if they're pitted or burned. It pays to be real fussy about distributor service. For example, good ignition point alignment is very important. So is correct ignition point gap. And I always double-check myself by hooking up the dwell meter to make sure dwell is within specs. In case of ignition trouble, it's impossible to overemphasize the importance of checking the secondary ignition circuits and cables. You can run a grounded test probe along the cables to test for leakage through the insulation. If you have any doubts about resistance in the secondary ignition cables, use an ohmmeter to test them. It's a good idea to check the cables and the cap without removing the cables from the cap.
That's a good idea. You know, You can't depend on your eyes alone to tell you whether cable insulation is good and cable resistance is okay. And right about now, will someone please turn the record so Larry and Jim and I can hear all the other things we have to say about cap? Before we get off the subject of ignition, do either of you have any suggestions on ignition timing?
We sure do, Tech. From what we've already said about cap, I'm sure everyone realizes that exact ignition timing is very important. But you'd be surprised how often we run into a job that isn't timed correctly because someone was careless about details. But let me explain. To set ignition timing correctly, you must sight straight at the timing marked tab. I've seen more than one case where timing was several degrees off because the mechanic was looking at the timing mark from a bad angle. The distributor vacuum advance line must be disconnected from the distributor and plugged before setting timing, so there's no chance of vacuum advance causing a false timing setting.
This is especially important on cap cars for two reasons. First, at specified idle, the throttle is right at the edge of the carburetor vacuum port. Second, a slight leak past the vacuum control valve could let manifold vacuum get into the act.
Exactly, Tech. And at this point, we haven't tested the valve yet. Now, here's another precaution. When setting timing, engine idle speed must not be higher than specified. If idle is too fast, you'll get some centrifugal advance and set basic timing too late.
Does that wind up your suggestions on ignition system service?
Not quite, Tech. There are a few other electrical items that can affect ignition either directly or indirectly. We always check battery condition and specific gravity. The battery cables, particularly the condition and the tightness of the terminals, is worth a quick check. The same thing goes for the primary wires and terminals.
You'll find everything Jim and Larry have covered on servicing the ignition system of a cap car in this month's reference book. As a matter of fact, the reference book goes into a lot more detail on ignition service. So let's get into the carburation part of cap service. Periodic inspection, evaluation, and adjustment of the carburetor is essential on all cars. In a cap-equipped car, idle mixture adjustment is quite critical, and adjusting procedures are somewhat different. So let's cover carburetor idle adjustment highlights.
That's a good idea, Tech. Before I touch an idle mixture adjustment, I cover all the preliminary bases affecting carburetor performance. I make sure all carburetor linkages and the choke shaft are clean and operate freely. We always service or replace the air cleaner. We also inspect and test the crankcase vent valve. If either of these are dirty or restricted, it'll upset carburation, affect performance, and increase emissions. Another item affecting carburation that's sometimes overlooked is the manifold heat control valve. We check to make sure it's free and operating correctly. Before adjusting engine idle speed on a carburetor equipped with a dashpot, the dashpot must be backed off so that it doesn't contact the throttle lever. Idle speed is adjusted with air cleaner installed, transmission in park, and on 6-cylinder cars, put the headlights on high beam.
You'll find engine idle speed on cap is higher than you are accustomed to. The higher idle speed is necessary because of the leaner idle mixture and retarded ignition timing. So be sure and set idle to cap specs. Since you'll need a combustion analyzer to check and adjust air-fuel ratio, you better get yours checked out and make sure you know how to use it. Do you have any suggestions along that line, Larry?
You bet I do, Tech. Make sure your analyzer is properly calibrated to handle the lean cap idle mixtures. 14:1 or higher. Instructions vary somewhat depending on the particular analyzer you have in your shop. Study the instructions, including the fine print, so you know how to use it. Incidentally, the higher the meter reading, the leaner the mixture. Without going through a step-by-step procedure, I'd like to pass on some of the things we've learned about idle mixture adjustments. I use a clamp to close off the intake manifold vacuum hose leading to the vacuum control valve. This is necessary because I haven't tested the valve yet, and I don't want to take any chances on vacuum leakage past the valve, upsetting the apple cart. A combustion analyzer is very sensitive, and it takes about 10 seconds for the meter to stabilize after each adjustment of the mixture screw. And you'll get better results if you don't turn the mixture screw more than 1/16 of a turn between readings. Final adjustment must be made by adjusting from rich to lean, not from lean to rich. If you tried to start with the mixture too lean, the idle would be very rough, and it'd be difficult to maintain specified idle speed. Speaking of idle speed, it's very important to maintain specified idle speed when adjusting idle mixture. If speed changes appreciably when adjusting mixture, readjust idle speed before proceeding with mixture adjustment.
Here's a point to keep in mind. In the case of carburetors having two mixture screws, a final independent adjustment of the mixture screws may be made to smooth out the idle. Just make sure this final adjustment doesn't put the air-fuel ratio outside of specifications.
That's a good thing to remember, Jim. Now, I want to tip you all off to the fact that on 1968 models, you're going to see some new carburetors with a different type idle mixture adjustment. Be sure and read your 1968 service manual before you tackle one of the new models. But we'll tell you more about that next month. Right now, I better let you fellas get back to your cap servicing lesson. What comes after idle mixture adjustment?
We check out carburetor vacuum, Tech. Carburetor vacuum will be between 0 and 6 inches of mercury if ignition timing, idle speed, and the air-fuel ratio are correct. If carburetor vacuum is outside these limits, I know I've slipped up someplace. To check carburetor vacuum, simply connect a vacuum gauge into the carburetor vacuum hose and clamp off both the distributor vacuum hose and the manifold vacuum hose. Next comes the vacuum control valve test. The vacuum valve test checks both the operation and the calibration or adjustment of the valve. The vacuum gauge is connected into the distributor hose, and the carburetor and manifold hoses are properly connected. Now remember, the valve is supposed to open on deceleration, so simply speed the engine up to about 2,000 RPM. Then release the throttle so the engine speed will drop back to idle. If the vacuum reading climbs up to about 15, you'll know the valve is opening, as it should. But you still don't know if the valve is properly adjusted. Here's how you tell. When you release the throttle, and after vacuum reaches maximum, the vacuum gauge should hold this reading for at least 1 second. This shows that the valve is staying open long enough. Next, the vacuum gauge reading should drop below 6 within 3 seconds. If it does, the valve is closing soon enough. If it drops too soon or takes too long to drop, the valve must be adjusted.
Since adjustment details are in the reference book, let's skip valve adjustment and explain some things they'll run into with cap cars.
Good plan, Tech, because there are some differences. For instance, at idle, a cap car won't pull as much vacuum as non-cap cars. That's because with cap, there's more air bleed past the throttle at idle. So don't expect 18 or 19-inch vacuum readings on cap cars. Don't be surprised if engine idle isn't quite as smooth on cap-equipped cars as it is on present models. Emission control laws don't allow us the luxury of going rich on idle mixture simply to smooth out engine idle. Whatever you do, don't blame the vacuum control valve if idle isn't as smooth as you think it should be. Remember, the vacuum valve operates only during deceleration and does not affect engine idle operation. We've already pointed out that higher engine idle speeds are specified with cap. Customers sometimes wonder what this will do to economy. Well, the leaner mixtures offset higher idle speed, so we don't find any measurable economy differences between cap cars and comparable non-cap models. It's important that you teach your owners to cam start a cold engine. That simply means pushing the accelerator all the way to the floor and then releasing it completely before cranking the engine.
The choke and fast idle cam will put the throttle in the best position for easy starting more consistently than the driver. You'll find more about below zero starts and hot engine starting in the reference book. Are there any more bits of advice you'd like to pass on before we wind up this session, Jim?
Just a couple of service tips, Tech. Good warm-up performance is dependent on correct fast idle speed and choke operation. So make sure fast idle, choke, and vacuum kick adjustments are as close to specifications as you can get them. Don't fudge or guess on these adjustments. Make sure the throttle valve is closing properly. A tight or binding linkage or a weak throttle valve return spring is bound to cause trouble. And that concludes my contribution for this session.
Thank you, Jim, and thanks to you too, Larry, for a real good introduction to CAP. The experience you've picked up should help everyone handle the CAP-equipped 1968 models. I'll be back next month to tell you all about those 1968 models, including more information on the CAP cars you'll be servicing. See you all next month.